we need to find all this stuff, and this person, Isaac, pick something. Okay. Talk me through it, just like I was absent yesterday.
First step is you got to find the degrees of the top function. So the top one is 1.
So up here, 1. Okay.
And then the bottom one is 2.
So I don't have to look at the other stuff, Isaac?
No.
You were right. What inequality goes there, Isaac?
Less than.
And what do you do when it's less than?
Y equals 0.
So horizontal asymptote of y equals 0. Just use that chart that we copied down. And it'll always be y equals 0. Raise your hand if you got that. Nice. Use green. Good job, Isaac. Henry, what do you want to do next?
The vertical function.
Okay, go.
First you factor it.
Okay. When you factored it, what did you get?
X. And then x minus 2 and x plus 2.
Good. Question. Can you cancel x's? You are correct. I don't know. Maybe it looks kind of weird. Maybe this would help you. I don't know. Crazy. What's a number right here? You could just put a +1 whenever you want. How about afterwards though? Plus, what number? 0. So, I don't know. Does that help you? To realize what it looks like or what it kind of is? It's a factor, and you're like, well, Mr. A, we usually cancel things that have parentheses on there. Well, they're there. You just don't have to have them there. Does that make sense? Okay. All right, Henry, we're trying to find vertical asymptotes. Now what?
You set the denominator equal to 0.
And what values do you get?
You get x does not equal 2 and negative.
Raise your hand if you got that. Awesome. Let's use purple. Good job, Henry. Erica? What do you want to do next? Do you want to find the x-intercept or y-intercept? X-intercept? How do you find an x-intercept? We're going to make y equal to 0. Tell me what to write, please. Okay, we have a y value. We're trying to solve for x. What would we do next? Yeah, you're going to make this a fraction. And now what, Erica? Everyone talk to your partner, 10 seconds. What do we do at this point here? Ready, set, go. All right, Erica, what do we do? You can cross multiply. Erica, 1 times x? becomes x. Erica, 0 times anything? So this is 0 times x squared minus x minus 2, and that is 0. So I have the ordered pair.
I need a quick signature from you.
Sure.
Just right here, that you let my student teacher come into your class and observe you. Here you go. Thank you.
Thank you. Thanks, Erica. Let's make that blue. Daphne, how do you find a y-intercept? Numerator? Denominator? Answer? Order pair. Raise your hand if you got that. All right. Let's put the information that we know, and then we'll. This will kind of give us some clues about table of values. Okay. So x and y intercept are both at the origin. Now, I kind of thought ahead and realized that my asymptotes are going to be kind of close together. So what I decided to do was 2 boxes for a value of 1. And I did that to kind of like zoom in manually. I don't know if that makes sense. So 0, 0. We have a horizontal asymptote. Brianna, from yesterday's lesson, can the graph go through the horizontal asymptote? Yes, it can. Purple. Remember, in my paper, I decided to do every 2. So -1, this would be -2. Why did I do that? +2. So 2 and -1. If you're going shopping this weekend, buy highlighters. Super helpful. Okay. Ruben, how many graphs... Where are you, Ruben? There you are, Ruben. How many graphs do you expect us to have? 1 graph? Ruben, count with me. Ready, set, go. Three. I expect to have 3 graphs. Now, look at the clues we're going to use for the table of values. I basically want stuff to the left. So let me write this numbers in first. So like -3, -2, -1, 0, 1, 2, and 3. Now you might be asking, how did I pick these numbers? Everyone say, to the left. I want values to the left. Okay, so if you think about it, you see the purple line? You see the purple line? Does that make sense? I need numbers to the left of -1. I want numbers between -1 and 2. And I want some numbers to the right of +2. Does that make sense?
Yeah.
Let's get one more in there. Let's put that into our calculator. I'm going to put that into y equals, and I'm not going to press the button graph. I'm just going to use the table of values. We've been doing this for several days, and I see some students are still telling Mr. Ng my graph isn't showing up on here. And I already know what's their mistake. The mistake is they're not using, what symbol is that, class? Parentheses. Use them. And also the subtraction sign and negative. Okay, those are the common mistakes using your calculator. All right. Parentheses x, close parentheses to show that's the numerator, divided by x squared minus x minus 2, or subtract or take away 2. Class, how do you get a graph? Zoom 6. Oh no! Oh no! We weren't supposed to look. What did I tell you to do? Table. How do you get to the table? Second. Okay, before you do that, let's double check. Second, go to table set. So second window. I press window. Press second window. And you should have this. It does not matter where your table starts. I do want my table to move by positive ones, or you can use decimals if you wanted to. Independent means, what do you want for the x values? I want the calculator to automatically pick it. Dependent are the outputs or the answers. I want the calculator to figure it out automatically. So we're going to go to table, so second graph. Look at that. So nice. It's basically saying, if I put in -3 for x, what's the answer? We have the answer. I'm just going to copy it. Class, we already know that the purple is error, or what's another word for error? Undefined. I'd rather write the word undefined. We already knew 0, 0. That was the origin, or the x and y intercepts, our blues. 1, -0.5. 3 is 0.75. And 4 is 0.4. And again, let's just say you don't have enough values in there. You can just go back and change your table set to having decimals. Maybe you want it to change by 0.5. And now you have more values. Does that make sense? So let me just go back. Whoa, what did I do? Stop. So hopefully those are the same values as mine. And now all I'm going to do is just graph it. -3, -0.3. So that's below. Maybe -4 would help. -4, -0.222. Uh-oh, I made a mistake. Remember, mine are counting by 2s. So that's -3, -4. Come on, mister. -3, -0.3. And then -4, -2.22. Zero, 0, we already know. 1 and -0.5. Uh-oh. Sorry. Remember, I decided to use a different scale to make this graph look bigger. So that's like -0.5. So 1, -0.5. 1, -0.5. So like right here. Three, 7.5. So again, this is 3. This is 2. That's like $1.50. Does that make sense? Right, 3.75, so that's 50 cents, and this is 75 cents. $4 and then 0.4, so 4, and then 0.4, so that's 50 cents, so it's a little bit below. Okay, let's see what our graph looks like. So is it okay if my graph goes through it? Let's predict. I think it'll do this. Maybe do -2? 0.5. Or it's okay if it goes through. I don't know what this one's going to do. Up or down? What do you think? Up? Did you look ahead? That's your guess? Okay. You can always erase. Is that fun? It's like drawing. Kind of looks like someone's head's down. Do you see it? This is their hand, and then this is their face. Does that make sense? Smile because they did their Khan Academy. Oh! We were close. Look at that. If I would have graphed like something like 1.5, then I knew the value would have gone down. Kind of looks like a tangent cotangent graph. Is that nice? We graphed a rational function by hand, pretty much. We just saved some time on the table of values, and you can see all these puzzle pieces kind of help us. And then you can go through and you can practice stuff like where is it increasing and decreasing, where is the domain and range, and all those good things.